Today we are going to talk about the producer-consumer pattern. Let's look at an example. Frame producer produces frames, right? It's a producer, and frame blender blends them together into one photo or video. This class acts as a consumer in the producer-consumer model. Why did we use this pattern here? Because earlier we had one class that tried to both produce and consume, and it was getting too complex. So we split it. The producer has a processed callback, which you pass in the initializer or constructor. And it has a function called stop recording. When you're done, you call stop recording. So basically what it does is a frame or an image is produced by this class in sequence, right? A sequence of images, one after another. And it starts when you construct the object and it stops when you call stop recording. And all of these are consumed by the frame blender. And notice that it's a push-based system, not a pull-based system. So there isn't a blocking get call on the producer. That would be a pull-based system where the frame blender is in control. Instead, we have a push-based system where the producer is in control. It invokes the callback whenever it has an image. The reason we chose this is that we didn't want to block the main queue. The stop recording function guarantees that the callback won't be invoked after this function returns, even for already enqueued frames. So this class uses a queue internally, but even the items in the queue won't be delivered after this function returns. And some of the capture uses multiple threads, but again, the consumer doesn't need to worry about all that. As far as they are concerned, it's a single threaded producer. And when you call stop recording, it stops. Right? This really simplifies the consumer. It doesn't have to handle multiple cases, such as data coming when it no longer expects. The frame producer can have ancillary functionality regarding production. For example, it switches camera. It applies the correct settings to the camera. And when you tap a smartphone screen to take a photo, the act of tapping it can cause it to shake, causing a blurry photo. So this class can apply a delay to prevent shake. And after it's done, it leaves the camera in a consistent state. So all this ancillary functionality regarding production can be in the producer, but not consumption related functionality. This class also enforces that there's only one instance at once. I think it has a Okay, never mind. I thought it has a check that ensures that multiple instances of this class aren't active simultaneously. It doesn't seem to have that check, but it could because it requires that to be the case anyway. So it could enforce that. So when we are talking about the producer-consumer model, in some use cases, it may not make sense to have multiple producers. So that's a fact you can keep in mind. And the producer delivers all its data in the main queue or the main thread, right? So which happens to be the same thread it is constructed on. That reduces the work for the blender. If the producer invoked its callback on arbitrary threads, then the consumer will have to synchronize. But the producer takes on that responsibility itself. So you can figure out which responsibility you want to assign to the producer and which responsibility you want to assign to the consumer. This producer can't be paused once it starts, and after stopping, you can't restart it. It's a single-use object. So add only the functionality that you actually need in your producer. There isn't a rule that says producers have to have a certain set of functionality, right? It's just a model adapted to your needs.